Welcome everyone. Today I'm going to show you a tour of the wind tunnel. My name is Sid Gunasekaran. I'm an assistant professor at the Department of Mechanical and Aerospace Engineering. And we use this wind tunnel for a lot of research projects, but also for teaching. I have students who have done several projects over the years. And we have had a lot of really good work from this tunnel as well. So let's go in and check out the wind tunnel. All right, so now you're entering the wind tunnel. When you enter the wind tunnel, this is what you see. What you're seeing here is the front end of the University of Dayton low-speed wind tunnel. So as you come closer, you would see this gigantic structure here is where the air enters the tunnel. And the first component that you see here are the screens. These screens, we have 6 of them in the tunnel, which prevents dust from entering the tunnel. Also, it helps reduce the turbulence, inside the test section. So when the air enters, it can be chaotic, it can be turbulent, but we don't want turbulent and chaotic air in the tunnel. The screens help actually get rid of those. All right. Now, as you can see, after the screens, you have a contraction. Now, the job of contraction is to take a low velocity air and squeeze it down to high velocity. It does so by actually reducing the area in a gradual manner. Now, the area ratio of our tunnel is 16:1. That means if the velocity entering the inlet is about 1 meters per second, by the time the air reaches the test section, it'll be around 16 meters per second. So that's the beauty of the contraction, is use conservation of mass. It squeezes the air down to a high speed. All right. Now let's move on and see where the next stage where the air goes. Now this room right here is a pressure sealed airtight room. The short form for this room is called plenum. A plenum hoses holds the test section that we're going to walk into. All right. In most tunnels we have a closed jet wind tunnel, which means the test section is surrounded by 4 walls, but ours is a little different. In our tunnel, we have an open jet wind tunnel. So the open jet wind tunnel, looks something like this. So as you walk in, you're basically walking into the wind tunnel, to the test section of the wind tunnel. So as you can see, inside this tunnel, there is no walls. You can basically walk in here, and you are now standing in the test section. All right. So this is where we do all of our tests. Before we show what we do in here, let me show you the rest of the tunnel. All right. So this is the test section. I'm sure we're going to come back to this. So as we walk along, what we see here is the diffuser, where the air, after passing through the test section, it enters the diffuser. The diffuser has an area which is expanding, which is opposite of what you see in the contraction. So the job of the diffuser is to slow the air down before it actually enters the fan. Now, the entire tunnel is driven by a high power fan, which you can actually see in here, right? So as you walk along, so this fan right here, so it has about 12 blades, which spins really fast, that creates a pressure difference before the fan and after the fan that helps draw the air in. The maximum tunnel or maximum speed the tunnel can achieve is around 100 miles an hour, which is really fast. I can imagine, if you are driving in a car at 100 miles an hour, you stick your hand out. By the way, don't do that. But if you stick your hand out, the pressure you feel, that's how much fast the tunnel can go. All right. So now let's go back into the test section, and I'll tell you all about the different type of projects that we do. All right. Or I'll show you the test setup that's already in the tunnel. All right. Well, welcome again to the test section. So right now, I'm going to show you just a basic type of experiment that we do here. Again, tunnels can be used to test a variety of aerodynamic applications, not just aircraft wings. We have tested sailboats, we have tested trucks, we have tested frisbees, we have tested golf balls. You name it, we have tested it. The only thing that we haven't tested is live animals, so I don't think that's going to change anytime soon. So we want to keep it that way. We don't want to test live animals in here. But one of the models that we test a lot is wings such as this. So this is a wing that's similar to what's used on an aircraft. Now what we have here is, we put the wing on top of a force sensor, and we can measure the forces on the wing as you pitch up and down. It's equivalent to pitching an aircraft up and down and trying to figure out what kind of forces it will generate. That allows us to understand, how to model those forces and what kind of geometry creates what kind of forces, which all helps in, better design the wings and better design aircraft. One other thing that is really cool about this tunnel that you don't find a lot in other tunnels is the capacity for the tunnel to actually change or simulate turbulence in the test section. So what that means is that, this contraption that you see here, these are what we call a shuttering system. Now, when the shutters, open and close, it pulses the air coming in. Now, you may all have been in an airplane where you may have experienced some turbulence, right? Now, turbulence is something, it's very hard to simulate, in any wind tunnel unless you have the right equipment to do so. So this tunnel is built specifically to do this type of testing where we can actuate the shuttering system to mimic turbulence of different varieties, turbulence of different magnitude. So you may ask why that's important. Well, turbulence may not affect the big aircraft because big aircrafts are really heavy and they don't get affected a lot. Even though there are incidents, even big aircraft get affected by turbulence. What this tunnel is mostly used for is to actually test small drones. If you ever try to fly a drone in a turbulent, even a hot summer day, it's really hard to do so because it gets thrown around a lot by winds. What we're trying to do here is basically understand how to, develop control methodologies or understand the aerodynamics behind, unsteady effects on a wing, on a quadrotor, on a propeller. Pretty much you can expose any models that we test here to unsteadiness. That even includes buildings, right? Because buildings do experience some gusts that affects the area around it. So we have tested models. We have tested full-scale models like aircraft, drones. We have tested half-span models like wings in here. So yeah, that's kind of the different testing that we do in this tunnel. Now there are also other applications where where we use this tunnel for, and it has nothing to do with aircraft or it has nothing to do with airplanes, but it has everything to do with agriculture. So let me tell you about that. What we're going to see right now is a special test section that is built specifically for this tunnel, right? So right here is what we call a spray drift test section. Over here, what you see is a nozzle. Now, using that nozzle, we spray different agricultural chemicals. Now, you may ask, hey, why this is shaped this way, right? So when we actually do the testing, we roll the entire section and put it into our wind tunnel that you just saw. So what that allows us to do is to test the spray coming from the nozzle in a wind of different velocities. Now, once again, you may ask why this is important. Well, I'm sure all of you eat food, right? And that food came from a certain field, and usually farmers who are growing that food use some kind of chemicals to make sure the plants are healthy, they're not overtaken by weeds. But in order to do that, they use chemicals and they spray the chemicals through this type of nozzle arrangement. Now, when they spray it, even if there's small amount of wind, it's going to carry that chemical away from the targeted zone. And what that's going to do is, wherever the chemical ends up, it's going to affect that area where it ends up. It can end up in another form where it's harmful, or it can end up in a water source, right? And we don't really want that. We don't want harmful chemicals to drift. So this effect is called spray drift. And one of the things that we do is we actually test different chemicals with different nozzle combinations to understand how much drift a chemical nozzle combination can do. All right. So this is a very interesting project. Again, it's still aerodynamics related, but the application is agriculture. Right? How cool is that? So the last project I'm going to talk about has to do with having propellers inside wings. Now you may have seen propeller-driven aircraft. You have seen wings, which is a fixed wing, right? You can have a mono wing, which is a single wing, or a bi-wing. But nowadays, with a lot of interest in air taxis and air mobility, some of the designs have propellers embedded in the wings. So if you actually see this wing right here, so this is what we tested in the past couple of years. We have put propeller inside this wing, and we have put this entire structure in the wind tunnel, and we have tested what is the performance of the propeller when you put that inside the wing of different structures. We can have a circular hole, we have tested with a square hole. So if you look at some of the modern air mobility or air taxi designs, they all have something like these. And we want to understand what are the aerodynamic effects of having a propeller in a wing, because the aerodynamics can be quite complex, right? So these are some of the projects that we do at UD, and there's a lot more that I didn't talk about. But if you are interested, you can always reach out to me. Have a good one. All right.
What we're doing is trying to study the different blockage effects based on different sized wings. So we have a small, medium, and large wing. And so there's pressure sensors and a force sensor that we're using. And the force can read all of the different forces that the wing is creating. And then the pressure sensors can read the coefficient of pressure, which you can relate to the velocity around the wing. And then you can kind of see how it changes based on the different size of the wing. And then we can use different corrections to kind of keep all of those the same, since even though the wings are different sizes, they have the same shape, and so they should have the same coefficients.